Lesson 4 through 6 is a continuation of what we learned last time. We were looking at more examples of functions. So something I said in the last lesson I just want to bring up again is that not all functions are going to be linear. So we easily can see nonlinear functions or linear functions. So just because something's nonlinear doesn't mean it's not a function. Also, not all functions can be described using numbers. We saw that a little bit last time when I showed you a soda machine and told you about how pushing one button can give you a certain type of soda. So you can always have functions that don't specifically have numbers. One doesn't always need to lead to two. It can be that the red button leads to you getting a Pepsi, whereas the blue button leads to you getting a Coke. As long as it's consistent, it's still a function. So now let's take a look at some of the rules of functions. So here we have this function. Futch is 22, Kibler is 28, Tor is 27, Gooch is 21, height is 26. And it's asking what the rule is of this function. It's essentially asking what is the output to the input. It's essentially asking where are these outputs coming from? What do these numbers mean? So this is kind of an example of a function that doesn't necessarily need to have numbers because obviously all the teachers' last names are not numbers. But then we have this output, Futch is 22, Kibler is 28, Tor is 27, Gooch is 21, height is 26. We're trying to figure out the rule, essentially, what it is that's going on that's giving us these outputs. Now, we can't write an equation from this or anything like that. We just kind of have to figure it out. Hopefully some of you might have caught on because you know your homeroom number and you think, oh, that's their room numbers. So when it's asking for the rule of the function, it's just asking you essentially what's going on to get those outputs. Let's take a look at another example. Here we have another function. It's asking again for what the rule is. So what do these outputs mean? Red is 3, yellow is 6, green is 5, purple is 6, and blue is 4. Now this is a function even though 6 appears twice. As long as an input doesn't appear twice with two different outputs, it still is a function. I'm not going to give you the answer to this one. I'm hoping that you will try to solve it yourself, and if you're still a little bit confused on what the rule is going on here, you can ask me during class. So let's move on now to the second page. We're now going to take a look at the difference between a discrete rate and a continuous rate. Discrete rate means that we are working with essentially whole numbers. We're working with integers. So in terms that you understand, what we're really talking about is the fact that these are things that we can't break down into fractions or decimals. So if we're talking about in terms of a word problem, there might be things that you won't break down into a decimal. So like books, you're not going to be cutting a book in half. Or if I want to talk about how many students can fit in a classroom, obviously you're not going to be cutting students in half. Or would you be cutting a room in half? And there's many, many more things that you would never ever cut into pieces, like pens. Pens don't work too well if you have a tenth of a pen. And there's a lot more things. So if you can think of more things that during a word problem we wouldn't want to break down, like number of cars, number of headphones, you of course can add them there. So a continuous rate is just the other one. We can use our fractions and decimals. And this makes sense. It's because it's continuous. So like time. Time is continuous. So it's okay for us to talk in terms of a quarter of an hour or a half of a minute. That's okay. It's okay for us to talk about cutting down time or maybe the volume of something. So drinking a tenth of a soda. Whereas if we were talking about cans of soda, we'd want obviously to talk about the whole thing, and that would be discrete. Some other things that would be continuous would be temperature. Because we can, of course, have a quarter of a degree, a half a degree when we're talking about, especially like in experiments. And a lot of times foods are going to be continuous because, of course, you can cut a cookie in half or you can have tenth of a pie because that's how much a slice is. So if something can be broken into pieces, it's going to be a continuous rate. If you can't break that thing into pieces, or in terms of the problem, it shouldn't be broken into pieces, it's going to be a discrete rate. So let's take a look at some example problems now. So we have this problem. A school bus can hold 40 students. How many buses are needed to take 90 students on a field trip? Now this is a fairly simple problem, because obviously if we have one bus, then that's our 40 students. If we have two buses, then that's 80 students. So we're almost up to the 95, but we need probably one more bus, because that one more bus can take all of our 95 students. So we're going to need 3 buses. If you had a different way of solving it, totally okay. Now here's where it gets tricky. It's asking us, is this a discrete rate or a continuous rate? Well, you have to think about the things that we're working with. We're working with students and we're working with buses. Are students something you should be cutting in half? Probably not. It's not really okay. And what about buses? Would a half a bus work very well? No, of course not. We're going to need to be working in terms of wholes. So this is going to be discrete rate. So because we have to work with whole numbers, just like here, we had to use 3 buses, even though 3 buses can hold way more than 95 students, we had to go to 3 buses because you can't have a fraction of a bus. So it's going to be a discrete rate. Let's take a look at one more. This problem says, my tea starts at 190 degrees Fahrenheit and starts to cool down. Every minute it drops by 10 degrees, and so we have to fill in a table. And then after that, we have to say if it's a discrete rate or a continuous rate. I'm not going to go through this one. I actually want you to try it on your own. So go ahead and try to fill in this table, which represents our function of time and temperature, and then let me know, is this continuous rate or a discrete rate? If you're having trouble with this, you can ask me about it in class, or you, of course, can comment in the comment section. And that's it for this lesson.